I think it was very smart of our organizer to keep the ugly data for the last day. Thanks, and as you said, I'm going to talk about ticks. My name is Najmeh. I am sitting here in the Department of Statistics doing a postdoc. All right, yeah. No, if you have been living in Sweden, you probably have seen ticks got a lot of attention this summer. You know, several reports go on about please take TBE vaccine, which is a virus carried by a typical tick we have in Sweden. So this particular National Veterinary Institute in Sweden, they got really interested in this matter. So they designed some sort of a web tool that you can basically import or like upload your image if you find an exotic tick. An exotic tick means a tick that we don't have it in Sweden as a common tick. So if you press this report tick, you're gonna go to the next page when you will see a lot of instances of images of ticks, and then you will ask to choose the one that is closest to the tick that you found. And you can already see that it's a bit difficult for a non-expert like me, that, you know, because they can get engorged, which means that they have fed on the host, so they can get blown up, and they look pretty similar, especially if they are not, if they are in nymph stage or engorged stage. But what do I mean by exotic things? To your left, you see the normal tick we have in Sweden, Day5 Fästing, or the Latin name is Exotes ricinus. It carries several bacteria and virus, also TB as I talked about, and we have been encouraged to get vaccine this summer. To the right, you see an exotic tick we don't have in Sweden. We didn't have it before. This particular one called hyaloma. It's originated in Middle East, North Africa, I believe, and the first instance of this has been seen 2018 and has been recorded by Giulio Grandi. It has been seen on a horse in middle of Sweden. That was the first we have ever seen this tick in Sweden. And this also carries several viruses and bacteria, but one called Congo fever virus, which is, there is a vaccination for this, for instance, in Africa, but we don't have that vaccination. And this one has particularly high mortality. So this can be very important for us to know if they're gonna start to become endemic in Sweden, this kind of exotic things. So these images that SVA has collected gave already, after I believe a bit more than 3 months, we have 18,000 images collected within this web tool. And they started to figure we should do something about automating this species detection. So they asked us to help with that part, and they sent us some data set. We immediately see two very big challenges. The first one was the data we got wasn't big at all. So as you can imagine, most of them are images of normal tick we have in Sweden. And another problem we have is that the quality of the images are pretty bad. So for instance, by quality, I mean that they contain a lot of noises. These are the images that we got, some of them, and you can see the focus is not particularly on the object in all of them. It can be even hard for a person, like an expert even, to detect what they are. So we thought for the quality, we do some sort of a pre-processing. As many of you has mentioned, you can choose some object detection model. We chose this faster RCNN plus inception ResNet model. You can kind of like detect the object, and to do that, we came up with some sort of a lookup query. So we thought we choose the labels that are closest to tick, can be ladybug, ants, and such. And if the model can detect either of these, it's gonna crop to that particular object, and of course scale it to the scale that we want. And this would be something that we were interested in. So we're gonna remove the noises. And this actually worked quite well. So we were able to, on SVA data, we were able to get a cropped image. More than 80% of the images will be able to be detected by this object detection. And let's take a look at some of the instances. In here, if you can see you can see my mouse, but tick is there, basically. The lower part of this branch that the person is holding. And so through it to the pre-processing stage, we get a cleaner image. And this one is a particular sorry for all of these ugly ticks, but I have been sitting and looking into this every day. So here is a very particular image that we have several ticks in it, and this is not something that is very common for us. But so we throw this and we just take the highest probability one for now. We don't look for other ones, and it is pretty much working quite well. But then the question is this actually going to help our classification? I remember in one of the talk they mentioned this, that probably better to annotate or doing such things and such, but I don't have that possibility, and I wanted to make sure that this kind of pre-processing is actually helping my classification. So we came up with three kind of scenarios. When we have original data, we just re-escalate it. When we use the pre-processing, and there we would define some sort of a flag. When the object detection detect this, they are good image, otherwise they are bad image. So then in the second scenario, we can throw all of those bad image away. We will end up having a smaller data set. And the third scenario would be that we crop, but we keep the bad images. So for these three scenarios, we chose a very simple model, a 3-layer convolutional neural network. We fix the initialization and run these three scenarios. And the one that gives us the one within the pre-processing and keeping the bad image was the best one. And these are the images that object detection could not detect. You can see some samples here. Okay, so then from now on, we're gonna stick to doing this, doing the pre-processing, keeping the bad image anyway, all gonna be the same scale. This is the second challenge we have, the size of the data, which is actually the biggest challenge. And you can see the distribution of the images we got from SVA. This is the typical tick we have in Sweden. And these are 3 of the 6 exotic ticks. And the other 3 we don't have because we believe, or they believe they're gonna come here, but they haven't been seen in Sweden yet. They are in neighbor countries. So these 3, for instance, for hyaloma that you just saw the picture, we only got 3 images. And this is nothing, we can't do anything with this for any kind of a species detection, so we realized we should collect some data. We collect the data from iNaturalist GBIF, and together with SVA, we have this kind of distribution of the ticks. And you can see beside the spider and the Rhizonos, that is the typical one, we have 6 other species that are exotics in Sweden. And I'm showing you these images because for me, first of all, I went blindly. I am not an ecologist and my knowledge about ticks were 0. So first I went blindly, but I realized I really have to have some sort of an expectation of my model. And then I started looking to the ticks. For instance, I have this Carius, and we have less than 30 images here, but it has very particular shape compared to the other ones. And for instance, this one, this Democentaur as well. So you kind of start to have some sort of an expectation. And with hyaloma, you see a very particular back shape, and we have see these striped legs. So these are good things to detect and build what we want to see actually. So so far we have seen collection of the data, throw it into pre-processing, have some sort of a clean data set, and now we're gonna do classification. And I guess you have also all seen that how overwhelming it is to choose a model. So many they are available. We picked all pre-trained and bunch of very different ones. We tuned them a little here and there. And the one that so far is doing the best is Inception version 4, which has many stuff in it, but it has been pre-trained on iNaturalist 2018, which is a very big help for this kind of a study. So I don't want to show you a lot of results, but what I want to show you is something that went wrong. So this is a result from this inception. It's a good result. And you can see, this is for me to detect what's happening during the training, for instance, with one score, F1 score. Is model learning during training? How's it going? Like, is it actually improving? And these are for each species. The black one is the weighted average among all of the species for F1 score. And let's take a look at it. For instance, Hamephasalis is this one. We have very low data. The tick look really, not interesting. So the model was very bad at detecting it. And we have, for instance, this Carius. Although we have less than 30 images, it's not doing so bad compared to the other one. This is the red one, hyaloma. And this is a good one, but then I was getting a very bad result with hyaloma for such a long time, and I couldn't realize what's wrong, because I had this, as I said, expectation of hyaloma with this striped leg to be able to, easy for model to detect it. And then I went into the model, to the data to see what's going on, and I saw more than 70 images of this particular species. Although they have been labeled research graded, they have been this, like images. So they basically label of lab something, you know. So more than 70, and that affected a lot the whole analysis. So far, as I said, 18,000 images has been uploaded. This is the distribution. Of course, unfortunately, it's not normalized by the population, so it's not so fair to the north, but I mean, that's what I got from them. And we have a lot to do. We need more data. I am thinking of actually all the way going to Uppsala all the way and grab some of these, you know, exotic ticks that they have actually, because people, they send them physically to them. So I'm gonna annotate them myself, take good pictures and such. And another thing is that we are starting to ask neighbor countries to also use this kind of web tools, because we believe we are sharing a species, so we could kind of collaborate together. And yeah, also the web tool needs a lot of updating to make it easier for me to use the data. Thank you.